Welcome to this video. It's a continuation on linear systems. Now I want to just clarify the elimination method, and I will make the assumption that for these linear systems we have integer coefficients. So I'm going to do kind of 3 videos on integer coefficients, what happens if there's decimal coefficients, and then what happens if there's fraction coefficients. All right, so this one is only going to pertain to integer coefficients, which is going to kick us off. Now, the linear systems basically means that you have 2 equations, 2 unknowns. So the equations are just lines. Now, I have talked about these linear systems before, and I do recommend that you watch a video possibly on the substitution method. All right, so I'm going to post a link in case you want to see that. Now, with these systems, okay, when we say integer coefficients, what I'm referring to is that the numbers in front of our variables, so for example, this, okay, is an integer. So 2 is an integer, and that's the coefficient of x. The coefficient of y here would have been -1. Okay, on the other line, you have the coefficient of 4. So, and then on the y, you have +3. So I'm going to assume that all of these are integer coefficients. It's kind of the easiest case to deal with. And if you want to watch the decimal and then the fraction coefficients, you can continue watching on my channel, and then you'll find those. All right, so I'll put a link up to the decimal coefficients up above there. Okay, so you'll see that. And then when you're watching the decimals, okay, so after watching those, if you want to see the fraction coefficients, once I finish the video, I'll put a link up above again. All right, so let's take a look at here. So I have 2 equations, 2 unknowns. So what's the trick? Now, when you're doing the elimination method, what you want to be able to do is, first, you want to be able to line up such that you have basically your x's are lining up. All right, like this. Then you have your coefficients in front, and then your y's are going to be lining up. So these ones are a little bit on a slant, but you have those coefficients there as well. And your ultimate goal is to be able to eliminate one of the variables so that you can solve for the other one. So remember, our goal is ultimately to solve for x and to solve for y, which is going to be a point somewhere, because these are just 2 lines. And that point might be the point of intersection. Now, they don't always intersect. Sometimes you have parallel lines, so you'll find that there's no solution. Or sometimes the lines are on top of each other, where the solution is actually the entire line. All right, and I talked about that in the substitution video that I pointed out, okay, in that first link. So here are coefficients on the x. So I'm going to kind of first tell you, when we're going to eliminate these coefficients on the x. So I have 2 and then I have 4. So those are my coefficients. So I have a 2 and then I have a 4. In order to eliminate them, you're going to be either adding or subtracting these. Now, if I add them, it's going to be 2 plus 4, which is 6. If I subtract them, it's going to be 2 minus 4, which is -2. So it's not going to eliminate anything for me. When I say eliminate, I want to have 0. All right, because 0 times x is going to be just 0, and that's the goal. So how do I do that? Well, it turns out that one of the easier methods is that you simply take your coefficients. So in this case, it's 2 and 4. And what you're going to do is you're going to find the lowest common multiple. If you forgot about the lowest common multiple and how to find it, again, I'll put a link up above. It'll be the last link here. And in that video, I describe, okay, lowest common multiple. It's something you should have covered in elementary school. So the lowest common multiple between 2 and 4 is 4. All right. So this one is not very difficult to find. Okay. So because it's 4, so notice I'm going to have to multiply this by 2 and then multiply this just by 1. So I'm not going to do anything. Now, those multiplying factors, so the 2 and the 1, what you want to be able to do is you want to take, okay, and then multiply. So let me erase this, or at least move it down. You want to be able to multiply, okay, this entire line by 2. So you're going to be multiplying this whole thing. And then you're going to be multiplying this by 1. Now, by 1 won't change anything for us. So this will just simply multiply the line by 2, but it's not going to change the line for us. So my coefficients, if I multiply by 2, so here if I multiply everything by 2, and you have to do both left-hand side and right-hand side, I would get 4x minus 2y is equal to 6. All right, so that's how my line has kind of changed in its coefficients. If I do that to the second one, so if I do it right here, well, then nothing will happen because I literally just have multiplication by 1. Now, what has this done? All right, so changing this to the lowest common multiple. What has it done is that these coefficients are now the same. So now I can either add them or subtract them to eliminate them. So now if I add 4 plus 4, it's going to give me 8, so it's not going to eliminate anything. But if I subtract, I'm going to get 4x minus 4x, which is going to give me 0. And that is the reason why we call this the elimination method, because you're eliminating one variable. And if you do that, so here, so I'm going to erase this. So if you do that, and so in this case, I like to kind of say what I'm going to do. I'm subtracting, and we typically might draw a little line because we're kind of like subtracting, the old school subtraction. So 4 minus 4 is going to be 0. So this is going to be 0x, okay, which is going to disappear for us. It's not going to be there. Now, I also have to do the same thing with all the other coefficients. So this minus 2, okay, so it's negative 2 minus plus 3. So it's minus 3, which is going to be negative 5. So that's going to be negative 5y. All right, so that's this and that. And then I do the same thing here. So 6 minus 2, which is going to give me 4. And this is gone. It's eliminated because 4x minus 4x is just 0. And notice what happens. Now you only have one variable, which you can easily solve for, because I can divide both sides by negative 5. So that will cancel. So you have y is equal to negative 4 over 5. And that's your answer for y. Now, once you know what y is, you can substitute y into one of the original equations, either this one or either that one. Okay, it's up to you. So for instance, okay, if I substitute it back into the original equations, so let's say to the first one, so it would have been 2x minus, now this is negative 4 over 5 equals to 3. And now I only have the variable x, and I can now solve for x and get exactly where those two lines are intersecting. All right, so this will be 2x, so the negative and negative will cancel, so it's going to be 4 over 5 equals to 3. I'll bring this over to the other side, so it's 2x equals 3 minus 4 over 5. All right, so that's what I have there. I can find a common denominator. All right, so the 3 really is just 3 over 1, right? Okay, so that is like saying it's 15, okay, over 5, right? So 3 over 1 is just 15 over 5. And 15 minus 4 is 11, so that's 11 over 5, 2x. And finally, dividing by 2 on both sides. So if you divide by 2, you're going to get x equals 2. 11 over 5 divided by 2, which is really just 11 over 10. So my point of intersection, so here it's 11 over 10 and negative 4 over 5. That's where those two lines are intersecting. All right, so those original two lines. And that's what you do in the process of the elimination. So the goal is to try to get rid of one of the coefficients. Now you might say, why did you get rid of the coefficient of x? Why didn't you just do coefficient of the y? And the answer is, it actually doesn't matter. You do whichever one is convenient for you. All right, so let's do a little bit harder example when the integers are actually a little bit bigger. All right, because the other two cases that we had, the integers were rather small, so it was easy to find the lowest common multiple. So here, okay, and we can just kind of pick on which one we're going to be eliminating, so either x or y. So I'll arbitrarily just, let's say, y. Okay, I'm going to try to eliminate y here. So my two coefficients here are 15 and 21, or negative 15 and 21. So in order to make them the same, again, what I'm going to be doing is I'm going to take these, okay, and find the lowest common multiple. So between 15, okay, and 21, what is the lowest common multiple? This one isn't as easy to see. And that's why, okay, so I pointed out you can watch that link that I provided for you for the lowest common multiple. So I'm going to do it by prime factoring, right, just to see, okay, what the lowest common multiple is. So right away, okay, so if I want to do this, I'm going to take 15. And now, what goes into 15? Well, 3 goes into 15, so I'm doing it by prime numbers. So 3 into 15 goes 5 times. Into 21 goes 7 times. So now to get rid of the 5, I'm going to divide by 5, okay, or factor out that, and then now this, okay, finishes that particular column, okay. And now the 5 does not go into 7, so we carry that down. And then finally, okay, to get rid of that 7, I would have to divide by 7. And now I have reduced, or have prime factorized both 15 and 21. And from these numbers, so these ones right here, when you multiply them, you will obtain your lowest common multiple. So now multiplying these, so 3 times 5 times 7, all right, so 3 times 5 is 15. And 15 times 7, okay, so I mean we can do that on the side, okay, so 15 times 7, all right, 7 times 5 is 35, carry that over, so that's 105. So notice that the lowest common multiple is actually pretty big, all right, so it's not very small like in the other cases. So what we have is, we basically have that 15 and 21, all right, so the multiple is 105. So that's what we want. So now, what does 15 have to be multiplied by to get 105? Well, I mean, that's division, right? So you have 105 divided by 15, which is just 7. And you will notice that's going to be one of the primes here. So I'm going to have to multiply this by 7. And the 21 would have to be multiplied by 5. So that's my lowest common multiple. Okay, and these are going to be my multipliers of the two lines. So what I have is, okay, so where my coefficient is 15, I have to multiply this by 7. And where my coefficient is 21, I'm going to have to multiply it by 5. So that's what I would have. And now, so that means I have to distribute this across. And yes, it's annoying, right? Because it's going to start getting bigger and bigger for us. So for example, 7 times 12, well, 7 times 10 is 70 times 2, so that's 84. So this is going to be 84x. Well, 7 times 15 we already know is 105 because that's the lowest common multiple. And then 7 times 2 is 14. So it's not that bad. And then we have 5 times this, times that, and times that. So 5 times 25, that's 125. X, and then, so that's going to be plus 105, y is equal to 100. Okay, so that's what I have. Let me bring this down. And now what I will do is I'm going to eliminate my y, which is what I originally wanted. Now, how do I eliminate it? So be careful because one is negative, one is positive. So in this case, I'm going to have to be adding the two lines together, right? Because negative 105 plus 105 is going to be equal to 0. So that's going to get rid of my y entirely. And now 84 plus 124. So I have 124. 124 plus 84. Sorry, 125 it was. So if I'm adding these, that's going to be 9. All right, this is 10. So that's 209. So 209x equals, so adding that is 114. So that's what I have there. Now dividing both sides, so I'm going to divide both sides by 209, 209, and then I get that x. Now this is not very pretty, but that's the answer. All right, so that's the x value. And now you would have to, again, so you're going to have to substitute. You have to take this x and then take one of the lines. So for instance, if we have 12, okay, x minus 15y is equal to 2. So I can take one of those lines and then substitute this x in it. So it's going to be 12, 114 all over 209 minus 15y is equal to 2. Okay, and now you would have to solve this for y in order to obtain your answer and exactly where those two lines intersect. So this is just substitution. Now, if someone gives you something like this, it would be a mean question because the fraction is rather big. But I wanted to give you this to kind of show you that the elimination method, it's not just for smaller cases. I mean, it's kind of useful, but you can use the elimination method, okay, for any. And the key trick is that lowest common multiple to get rid of, okay, whatever variable you do not want. All right, so I'll stop it here. I mean, for anybody else, I guess you can put in the comments what the value of y actually was. You can keep it in reduced form, and that's how you would do it. All right, okay, so thanks for watching. I know it's a little bit longer video, but I wanted to provide these examples for you. Okay, see you in a future one. Bye, everybody.